Did you ever ponder over the mistakes that even a genius like Einstein made during his scientific endeavors? The name Albert Einstein is synonymous with brilliance and innovation. Revered as one of the most exceptional minds in the history of science, Einstein revolutionized our comprehension of the cosmos. His groundbreaking theories of relativity reshaped the way we perceive time, space, and gravity. However, Einstein was, after all, human. And like all humans, he was not exempt from making mistakes. His intellectual voyage was punctuated with a number of notable errors, misunderstandings, and revisions. But these instances of fallibility do not diminish his genius. Rather, they humanize him, breaking down the perception of Einstein as an infallible demigod of science. These errors provide us with a window into the scientific process, a process that is far from straightforward, often filled with trial and error and always evolving. But these weren't just any errors. They were Einstein's errors, intriguing, enlightening, and even controversial in their own right. They offer us profound insights into not just Einstein's thought process, but also the broader context of scientific discovery. They remind us that science, at its core, is a human endeavor, marked by both triumph and failure. In this video, we will delve into some of Einstein's most captivating errors. We'll explore their origins, their implications, and the lessons they provide about the scientific process. From the cosmological constant, Einstein's self-proclaimed biggest blunder, to his resistance to quantum mechanics and his unfulfilled quest for a unified field theory, we'll examine how these errors shaped Einstein's work and the field of physics. So fasten your seatbelts and get ready for an enlightening journey through the cosmos, guided by none other than Albert Einstein himself. To err is human, and Einstein was no exception. In every error, there's a lesson to be learned, a new perspective to be gained, and a story to be told. Start by examining one of Einstein's most well-known blunders, the cosmological constant. In 1917, Einstein modified his original equations to accommodate a static universe, introducing what we now know as the cosmological constant. This was a time when the prevailing cosmological view was of a universe that neither expanded nor contracted. It was a universe that simply existed, unchanging and eternal. To fit this view, Einstein had to tweak his equations of general relativity. But how did he do it? He introduced a new factor into his equations, denoted as lambda, or the cosmological constant. This constant acted as a repulsive force, counterbalancing the attractive force of gravity. Without this addition, gravity would cause the universe to collapse onto itself. With the cosmological constant, the universe could exist statically, with all its celestial bodies held in a delicate, unchanging balance. This was Einstein's vision of the universe, a vision that aligned with the scientific consensus of his time. It was an elegant solution to a complex problem, a testament to his genius. But it was also a testament to his humanity, his ability to err. Because, as we would later discover, the universe was not static. It was expanding. When this expansion was first proposed by Georges Lemaitre and later confirmed by Edwin Hubble's observations in the late 1920s, it shook the scientific community. The universe was not a fixed tapestry of stars and galaxies, but a dynamic, ever-changing entity. This revelation rendered Einstein's cosmological constant unnecessary. The universe did not need a repulsive force to prevent its collapse. It was expanding all on its own. Einstein, acknowledging the error of his assumption, reportedly called the cosmological constant his biggest blunder. It was a mistake, yes, but one that would have profound implications for our understanding of the universe, as we would come to see later. But for the time being, in the face of an expanding universe, Einstein's cosmological constant seemed out of place, a relic of a bygone cosmological view. But soon enough, this modification would be deemed unnecessary. The late 1920s brought a significant discovery that shook Einstein's static universe concept. Edwin Hubble, an American astronomer, took center stage in this scientific breakthrough. With his observations, he unveiled a universe that was not static, but expanding, a concept that contradicted Einstein's cosmological constant theory. Hubble's evidence was compelling. He showed that galaxies were moving away from us, and the farther they were, the faster they were receding. This movement suggested an ongoing expansion of the universe. Einstein's cosmological constant, devised to keep the universe at a standstill, suddenly seemed superfluous. Einstein reportedly referred to the cosmological constant as his biggest blunder. But science is full of surprises. In a delightful twist of irony, the once discarded cosmological constant has made a comeback in modern cosmology with the discovery of dark energy, indicating that Einstein's blunder might not have been a blunder at all. Ironically, this biggest blunder of Einstein might not have been a blunder after all. Einstein's relationship with quantum mechanics was far from a love story. Now, that's a bit of a plot twist, isn't it? We know Einstein as a titan of physics, a man whose name is synonymous with genius. Yet, there was one aspect of the scientific frontier that he found unsettling: quantum mechanics. Einstein played a pivotal role in the early development of quantum mechanics. His explanation of the photoelectric effect, which demonstrated that light has both wave-like and particle-like properties, was groundbreaking. This work earned him the Nobel Prize in Physics in 1921. However, despite his contributions, Einstein found himself at odds with the very theory he helped germinate. At the heart of his discomfort was the probabilistic nature of quantum mechanics. This theory suggested that at the quantum level, the universe was fundamentally unpredictable, and that certain aspects of it were governed by chance. Einstein, however, was a firm believer in a deterministic universe, one where every event is determined completely by its preceding events. He famously quipped, "God does not play dice with the universe," expressing his skepticism about the randomness inherent in quantum theory. In 1935, in an attempt to challenge the completeness of quantum mechanics, Einstein, along with Boris Podolsky and Nathan Rosen, proposed what is now known as the EPR paradox. This thought experiment led to the concept of spooky action at a distance, or quantum entanglement, a phenomenon where particles become interconnected, and the state of one can instantly influence the other, no matter the distance between them. This concept, as mind-bending as it was, stood in stark contrast to Einstein's preference for deterministic theories. This resistance to quantum mechanics, this quest for order in the perceived chaos, led Einstein down a new path. Einstein's resistance to quantum mechanics led him to embark on a new quest. This quest, as we'll see in our next scene, was the pursuit of a unified field theory, an attempt to weave all the fundamental forces of the universe into a single theoretical tapestry. But, as with any great story, this quest was not without its challenges. Einstein spent the last years of his career on a quest that remains unfulfilled in physics. Consumed by the ambition to integrate all the fundamental forces of the universe into one grand blueprint, Einstein embarked on the pursuit of a unified field theory. This was no small task. Picture this: a single theoretical framework that explains everything from the tiniest particles to the most massive cosmic bodies, from the weakest forces to the most powerful. It was a quest for the ultimate simplicity underlying the apparent complexity of the universe, the ultimate dream of a scientist, if you will. But even for Einstein, a mind that reshaped our understanding of space and time, this proved to be a formidable challenge. Despite his tireless efforts and relentless dedication, his quest ended in vain. Einstein's unified field theory remained an elusive dream, a theoretical white whale that he never managed to capture. But let's not be too quick to label this as a failure. In the grand scheme of things, Einstein's unsuccessful endeavor was a stepping stone, rather than a stumbling block. It highlighted the complexities of trying to weave together the fabric of the universe, sparking further interest and research in the quest for unification. Einstein's pursuit paved the way for groundbreaking theories that have since emerged, like string theory and attempts at developing a theory of quantum gravity. His work, even in its imperfection, became a beacon guiding future explorations into the unknown realms of physics. So, while Einstein may not have reached his final destination, his journey was far from fruitless. His ambitious quest, even in its unfulfillment, left a profound impact on the scientific community and continues to inspire scientists today. Remember, science is a marathon, not a sprint. Each step, each stumble, each wrong turn only brings us closer to the finish line. And in this marathon, every runner contributes, even when they stumble. Einstein's failures were not just his alone, but part of the larger narrative of scientific progress. Einstein's errors were not mere blunders. They played a significant role in advancing scientific discourse. They acted as catalysts, sparking debates and discussions that propelled the scientific community forward. For instance, Einstein's skepticism of quantum mechanics led to essential dialogues and experiments, including the renowned Bell's theorem, affirming the non-locality predicted by quantum mechanics. Moreover, Einstein's willingness to revise his views, such as his retraction of the cosmological constant, symbolizes the evolving nature of scientific understanding. Knowledge in science isn't static. It grows, adapts, and changes as new information comes to light. In fact, this evolutionary process is at the very heart of scientific progress. So were Einstein's errors really mistakes, or were they stepping stones leading us to a deeper understanding of the universe? Perhaps it's all a matter of perspective. Indeed, the path to scientific discovery is paved with errors and revisions, as the journey of Einstein clearly demonstrates. Thank you for watching our video on Einstein's errors, the human side of genius. We hope you found it insightful and it sparked your curiosity about the world of science. What did you find most intriguing about Einstein's errors? How have they changed your perspective on scientific progress? Share your thoughts in the comments below. We'd love to hear your insights and engage in a thought-provoking discussion. If you enjoyed this video and want to explore more fascinating aspects of scientific discoveries and the human side of genius, make sure to subscribe to our channel. We're constantly updating with new content that dives into the intriguing world of science and its many faces. Remember, even in errors, there's a path to discovery. Stay curious and keep exploring. Until next time, keep questioning, keep learning, and most importantly, keep making mistakes. After all, as we've seen with Einstein, they might just lead to the next big breakthrough.